All right. Hello. My name is Giovanni Viscarando. Um, I'll be doing this video for part one. Um, Sorry about that. I worked through parts A through C, and Ty worked through parts G to F. But I'm gonna try to do the video for the entire part one. So yeah. Here we go. The first thing, we have our workbench open. So we are going to choose Fluent, drag that over there. And then we are going to do geometry. We're going to right click. Uh, Hold on. All right, sorry about that. I had to restart my bench because it was up. We're going to bring that. We're going to right click geometry. We're going to do new space claim because for some reason the discovery didn't quite work. So I'm just going to do space claim to try to make it better. I'm going to pause it so that and open it when it loads. All right. So space claim is open. So I'm going to click that view. We are going to go to File. We're going to go to Space Claim Options, Load, and then we're going to go to Units, Metric. We're going to put this in meters. Okay, there we go. Now everything is going to be in meters. I'm just going to zoom out. Rectangle. I'm going to click Origin. And just kind of zoom out like that. And then now we have our box. Dimension this, and it changes to 10 meters because that's our blockage. Constraints. What? Rectangle. That. Mention this. 10 meters. Mention this. 10 meters. Now we're going to zoom in on a square. Why is it in millimeters? Okay. I guess I have to do that again. Base claim options. Sorry. Um, Units. It's in meters. Okay. There we go. I'm just gonna drag this over here, here. Yes. And select. All right. There you go. Now you can see it's 10 meters by 10 meters. Actually, now I'm gonna do construction lines from the middle. There. That should be the middle. Circle. Right in the middle. 1 meter. Dimension 4. I know it says 1 meter, but sometimes it might do like 1.0007 meters or something like that. I just want to make sure that it's 1 meter across, Good. And I'm just gonna cut out these lines over here. Got our nice shape. Excellent. There we go. Um, I'm gonna hit pull. Boom. There's a rectangle. And I'm gonna go to design, and I'm gonna click select. Edible. And yeah, groups is open. Good. Like that. We do create name selection. We call this inlet, not inlet, inlet. I'm gonna click this one. Hit create new name selection. Call this outlet. Um, we're gonna hit this one. This bottom from here. And we're gonna call this one top. And then here, hit, call this cylinder. That's our cylinder, which has diameter 1 meter. Um, that's going to be our geometry. Give me 1 second. Sorry about that. Now that we have our shape, we're going to go back to Workbench. Uh, Geometry updated. We're going to double click Mesh to open it, and then we're going to wait for Mesh to open. So I'm going to pause until it opens. Now that we have our mesh open, first we're going to go click Mesh, and then we're going to change the element size to 0.02. Oh, sorry, not 0.02, just 0.2. There we go. And now we're gonna right click mesh and insert sizing, and then this type, we're going to select this right here, apply. All right, we do element size. We're gonna do 0.03. All right. Um, all right. And then let me see, we're gonna hit generate mesh. Generate mesh. Sorry, I was supposed to click mesh and then generate. Boom. There we have our mesh. 1 second. I'll make sure. All right, now that we have our mesh, we are going to go back. I'm going to update this. Right click, date, update, good. Now we are going to click setup. Wait for that to load. We're going to do double precision and then hit start. And I'll pause until it loads. All right, now that we have this in our Fluent, I'm just going to bring something onto the screen real quick. So right here, I'm just going to open it. Here we have our air properties for part one. So we're going to have to change density and the viscosity. The speed of sound will automatically change. Um, just going to bring this back over here. just so I can look at it on my other screen. So we're going to go to models. Well, first we're going to turn viscous because our first flow is going to be um, uh, um our first flow is going to be Inviscid. Sorry about that. So look over here. I don't know why I got so tiny. I'll make it bigger. Oh, it's weird. But I clicked Inviscid. You can kind of see it. Um, I don't know why I did that. Now, right here, you see it says Inviscid. Then we're going to go to materials. We're going to go to air. We're going to go to edit. Uh, right here. Why is it like that? Go like that. Um, hold on. That's weird. I was able to change the viscosity. Um, Give me 1 second while I figure this out. All right. Sorry, that's what I did wrong. I was supposed to change this before I change the flow. So we're gonna make density 1.112 kilograms per meter cubed. And then this is going to be 1.758. And then we're gonna hit change create. Then we're gonna hit close. Then we change this. We're gonna hit edit to Inviscid. There you can see it better. Okay, there you go. Um, then we are going to go to boundary conditions. We are going to change we're going to go to click inlet, edit, and then we are going to change that to 5 miles per hour. And then hit apply, and hit close. Then we're going to go to outlet, hit edit, make sure that the pressure will be 0. Hit the pressure 0, hit apply, close. And then the top and bottom, we're not going to make them walls, we're going to make them symmetry. So we're going to change bottom symmetry, apply, close. And then top, we're also going to change to symmetry, apply, and then close. And then the cylinder is going to stay a wall. There you go. All right. Now from here, we are going to go to initialize. So we're going to go to solutions, initialization, hybrid, good. We're going to initialize. Okay. And for run calculation, we're going to use 500 iterations. I'm going to hit calculate. See what happens. We're going to let it run. Okay, calculation complete. So for part A, uh, they are going to want our velocity contours. So we are going to go to results. We're going to go to graphics. We're going to go to contours. And then we are going to do velocity, velocity magnitude. We're going to do surface. We're going to include contour lines. And then actually anything. Play. And that's what our velocity is going to look like. However, they also want the streamlines. So now that we have that, we're going to go to path lines. Um, and we're going to go to velocity. We're going to do inlet surface. Um, Give me 1 second, folks. I will be right back once I figure this out. All right, friends. So I figured out what I was doing wrong. So this is going to be the velocity contours. However, they also want the streamlines. So we're going to go to path lines. Accidentally already made it, so I'm going to just delete it and then we'll do it again. So you're going to double click path lines. Actually, get rid of this. We're going to bring this over here. Um, we are going to go to velocity magnitude, and then we're going to go to inlet. And then, boom, this is what our velocity streamlines are going to be. However, to combine them, we're going to go to scene. Uh, we're going to use contour and path lines. Let's see what happens. I'll go like that, around 13. I'm going to save and display. Sorry about that. So you can see them kind of together like that. Let's see what happens when I up the transparency all the way. Save and display. Oh, all right, not all the way. Let's go 50, 50. Let's see what it looks like then. Display. There, look, there you can see the streamlines along with the velocity contours. All right, boom. So that's gonna be the thing for part A. Then for part B, we have to find the pressure contour. So we're gonna go to contour. We are going to go to pressure, static pressure. We're going to go just hit in display. Oh, let me hit the contour lines. Hit in display. These are going to be our contour lines for our pressure, static pressure. So as you can see, it's opposite of velocity, obviously. Um, yeah. So that's going to be part B, really simple. And for part C, we are going to go to our plots, go XY plot, because they want us to plot um, I apologize. They want us to plot the velocity distribution on the surface. So we're going to go to XY plot. We're going to go to velocity magnitude. We're going to change this to curve length. And we're going to hit cylinder. Uh, we're not going to write the file just yet. I'm just going to do save plot, see what it looks like. So this is what it looks like. Don't mind that line right there. But what we're going to do is going to write to file. And then, because again, they want it all on one graph. So we're going to put that together in a graph, but I'm not going to show you. It's the same thing that we've been doing for the past 3 projects, where you save it, like you write, and you're going to name the file. I'm going to call this Inviscid CSV. Actually, because I rated it before, so I'm calling Inviscid. Inviscid uh, video. Then I'm going to change this to all files. I'm going to save it to my thing, and then okay. And then I'm going to open my files, which appeared over here. Sorry about that. My files appeared over here. Uh, just going to look up in this video. I'm just going to open an Excel file over here. Opening an Excel file. Oops. Excel file right here. So we are going to get rid of this. Delete. Okay. And then we're going to click column A. We're going to go to data. We're going to go text columns. Next, 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 next. Finish. And then to separate it, boom. Right? Um, we're just going to move all this up. Let me get rid of this. We're going to move all this up. Select all these again. And then from here, we're just going to move it up. It looks better. All right. And we're going to do these for all of the flows. So I'm not going to repeat this because this is really tedious. But I'll show you the graph and then I'll show you what it looks like combined. Um, yeah. I'm going to close this. Now we're going to go do our viscous laminar. So for viscous laminar, we are going to go back models. We're going to change this to laminar. I don't know why I said it like that. Hit OK. Then we're going to go back to inlet. And if you look back on our project, it says that the velocity for laminar is going to be 7 meters per second. We're going to go and change that because it currently is 5. We're going to go to boundary conditions. We're going to go to inlet. We're going to go to edit. I'm just going to change that to 7. Apply, close. Again, that's all we really have to do. We're going to go to solution. We're going to initialize it to make sure that it has the changes. Okay. And then we're going to go to run calculation. This time we're going to set the number of iterations to 1,000. And now we're going to hit calculate. This is going to take a while, so I will play the video when I'm done. All right, as you can see, the calculation is complete. So I'm going to hit OK. Then what we're going to do now is we are going to go to contours. I'm just going to create it again. We're going to go to velocity, velocity magnitude. Then we're going to hit contour lines and then save and display. And look, as you can see, it's supposed to have a long, smooth wake, which implies that it's laminar, which means that we're doing well. Excellent. Um, then I'm going to hit path lines, create another path line. We're going to do changes to velocity, velocity magnitude, go inlet, and save display. See, that's what our velocity lines are going to look like, the path lines at least. And then we're going to go to scenes, another scene of uh, path lines 2 and contour 3. And we're going to go about 50, 50, save and display. And boom, that's what it's going to look like. For part A for our laminar flow. Boom, pretty easy. And then for pressure, we're going to go back to contours. Then we'll go static pressure and then hit apply. This is for part B. Oops, sorry, I forgot these contour lines. Boom. That's what our static pressure is going to look like for part B, which again makes sense since the opposite of the velocity. And then hit X. Then we're going to XY plots. We're going to do velocity through curve length on the cylinder. As you can see, it should be 0 because of the slip. So yeah, there you go. And again, it's right to file, right to file, right. We're going to call this one um, laminar video CSV files, all files. We're going to click this folder and OK. And then, the thing's going to come up. I'll show you what it looks like after. Now that we did that, I'm just going through A through C, and then I'm going to do D through F after, if that makes sense. Sorry, because again, I did D through A through C, so I know how to do this. D through F is going to be a little bit more challenging since I didn't do that. Yeah. Now we're going to go back to, all right, we're going to go back to here. We're going to change this to K omega to equations. Let's turn SST on. We're also going to turn curvature correction on and hit OK. Then we are going to go back to boundary conditions. We're going to change inlet. We're going to edit because again, on our document, we said for um, turbulent, it's going to be 15 meters per second. So we're going to put that back over here. We're going to change this to 15, 5, and close. And that's all we really have to do. Now we're going to initialize again. So go to solutions, initialization, initialize, yep, and okay. Run calculation. Sorry, we have to wait for the initialization. Sorry about that. I'm going to stick with 1,000. We're going to hit calculate. We'll wait for this to finish. All right, the calculation is complete. So again, we're going to go to contours. What the velocity contour looks like. We're going to go velocity, velocity magnitude, and contour lines, hit save display. Boom. As you can see, that one has shorter wake. But yeah, that's the thing for turbulent. Close. Now we're going to go to path lines. I'm going to do velocity, velocity magnitude, inlets, save display. That's what it's going to look like for turbulent. Again, what it should look like. Perfect. Then we are going to, well, let me move this again so you guys can see what it actually looks like. Close. And we're going to go to scene. Make this a little bigger. All right, so now we're going to use contour 5 and path lines 3. Again, divide that 50, 50 in both. And save and display. And boom, that's what it's going to look like with our contour lines and our streamlines for our part A. Now we're going to go to contours for our pressure, static pressure. We're gonna do contour lines, hit display. Great. See is the opposite. Um, move this out the way so you can see the values of the numbers. Boom. Okay. And again, that's for part B. So we did all of part A, did all of part B. And then for part C, it's going to be the same thing. We can go to XY plot. Y plot, we're going to do velocity magnitude of the curve length on the cylinder. Save and plot. And again, it's going to be 0 because of the slip conditions. Yeah, there you go. That's for A, B, and C. And then give me 1 second while I put them all together. Oh, wait. And then, yeah, we're going to write the file, right? I'm going to call this Fluent video dot CSV. All files. Going to hit save here. And okay. Now we have that. I'm going to show you what it looks like with the graph. So just give me a few minutes and I'll have that up and ready for you. Because again, we've done this. It's just tedious work at this point. Oh, sorry, I didn't know this was still recording. I thought I'd. All right, so I'm gonna have to edit that out the video. But yeah, this is what it looks like. Sorry that took so long. But yeah, this is what the graph is supposed to look like. Um, yeah. And again, the velocity on the surface of the cylinder for Inviscid, up and down. For laminar and turbulent, they're going to be 0. Now let me pause right here. All right, so now we're going to go to the pressure coefficients. So we're going to go to XY again. Um, we're going to go pressure instead of pressure. We're going to click pressure coefficient. Again, this is part D. Change that to curve. And you do surface. Uh, 1 second. Should be cylinder. There we go. So, okay, cylinder. Sorry, I don't know why I didn't see it. Save and plot. And that's what it should look like. Cylinder. I guess Tyler did something different because he got something else. But yeah. Oh wait, that's because this is for turbulence. Should be right. Um, we'll see. Give me 1 second. Sorry about that. So this is going to be the pressure coefficient for turbulent. Um, 1 second. So again, we're going to not in the plot. All right, pressure coefficient. Then we're going to write the file. Uh, right. We're going to call it turbulent p dot csv. All files. Okay. And then we're going to basically do this for each flow again. But before I do that, uh, 1 second. I'm so sorry that I keep pausing like this. Well, my friends, I'm sorry about that again. I just want to make sure I was doing something right. Um, so yes, this is going to be our coefficient of pressure. Sorry, pressure coefficient for turbulent. Um, and then I'm going to try this again because I was doing something on the other thing, but I messed up. So I'm going to go to reports. I'm going to go to forces. Um, then I'm just going to click print. And then, actually, hold on. Um, yeah, this is going to be our forces right here, which is we're going to need for part E, which is our drag coefficient. Um, yeah, again, this wasn't my part, but this is what Tyler told me to do, and he said it looked right. So I'm going based off what he says, because again, this was his part, and they fairly match. Now we're just going to do the same thing. We're going to go backwards now. For we're going to go back to laminar. Boom. Could have done this all in one go now I think about it, but laminar. We're going to go to boundary conditions, go inlet, go edit. We're going to set this to 7. Apply. And then close, and then we're going to go to initialization, initialize, we're going to hit OK. We're going to run the calculation, again, 1,000 iterations, and calculate. Wait for this to load. Okay, calculation is complete. So we are going to now go to, again, another XY plot. We're going to go to pressure. We're going to go click pressure coefficients, cylinder, and then we're going to go save and plot. And this is what our plot is going to look like for pressure coefficient. Seems about right with what um, Tyler got. Again, as I was, oh wait, that's why, hold on, I forgot to change this to curve length. Sorry about that. There we go. That's going to be the curve length. Sorry. This is what it should be. Um, yeah, that's going to be curve length is for sorry, not the curve length, the pressure coefficient distribution on the surface of the cylinder. Um, again, we're going to write the file, write, we call this laminar .cp, .csv, all files, okay, and then it wrote, and then again, the same thing is going to come up, and then we're going to exit out of here. We're going to go to reports, go forces, go print, and boom. That's what we're going to get for our coefficients. Boom. And again, Tyler said that this is correct, so here goes what he says. So again, that's C and D for turbulent and laminar. And then finally, we are going to go one more time. We're going to change this to Inviscid. Okay. Inviscid now. Now we're going to go to boundary conditions. Go to inlet, go to edit. Again, we're going to make this 5 flag. Solutions initialization. Initialize, okay. Time. Okay, initialization is done. Then we're going to set this to 500 like before. And then calculate. I'm going to wait for this to calculate. All right, it's complete. We're going to go back to XY plots. We're going to do another one. Go coefficient, curve length, plots. And this is what our should look like. Yeah. This is what it's going to look like for Inviscid. Um, just make sure that this is the Inviscid. We have that. Let me go back to class 6. Big plot. And then we are going to go to force again. We're going to go to forces. Go to print. And this is what our going to look like for coefficients. Yeah, that's how you're going to get all of those things. Show you real quick what it looks like, what Tyler did when he combined everything. Again, this is D. This is what they all look like combined right here. The turbulent, laminar, and then viscid is more of a straight line. And these are the drag coefficients compared to Reynolds number. And then if you want to pause here and read it, this is what I did for part F. So read here so you can read it. Yeah, that's going to be project 1. I'm sorry I wasn't as confident in parts D through F, but again, that wasn't really my part. I was kind of just following his instructions, but Tyler did do it better than me. So there you go. Thank you so much.